So hello everybody and welcome to my first YouTube video on what is a derivative. So the goal of this video is going to be to understand the formula for derivatives and to be able to do an example with the formula. So the definition of the derivative is it's just slope of the tangent at any point x of the function f of x. So what this means is that we're trying to find the slope of the tangent at the point x that touches the function only in this one point. So the best way to approach this topic is by the slope of the line. So you already probably know this, that of a function y equals mx plus q, you're able to find out m with the help of change over y divided by change in x. So let's just draw a graph with a y coordinate and x coordinate and draw a straight line. And so now here, let's just take points. So a point on the x-axis, 2 points on the x-axis, and 2 points on the y-axis, and create a triangle. And with this change in y and change in x, we're able to calculate the slope of this line. And this example is quite helpful, so it helps us also for the slope of the tangent. So let's again draw a graph with the y-axis and the x-axis on the positive side, and let's just take any function. So we're going to take a function that looks similar to a parabola, and now we just take any point x. And to get to the value of this point x, we have to put in x into the function, so the value equals f of x. And then we take another point, and our goal is that red line, so we want to know the slope of this tangent at this exact point. So we take another point, and this point is defined by x plus h, so we could just take any variable, but h is commonly used. So x plus h, and to find out the value, we have to put in x plus h into the function. So now we got, again, this triangle, which is the change of x equals to h, and the change of y equals to fx plus h minus f of x. So now we just created a line, and we know the slope of this line, but this doesn't give us the slope of the tangent. So now to get the slope of the tangent, we have to think about another concept, and these are limits. So the limits allows us to make h infinitely small, but not reaching 0. So in order to finish this formula, we have to take the limit of h going to 0. So let's just write that down. So we have f prime of x is equal to fx plus h minus f of x divided by h. So this is the line which we found out before. Now something is missing. So the limit of h going to 0. So this is the missing point. So we write limit h going to 0, and again the expression. And this is the formula to calculate derivatives. So perfect already. And now let's just do an example. So let's just take an easy function like f of x equals to x squared and calculate the derivative of that with the help of the function. So here again, very important, that's why I marked it again in red. It's important that you write the limit of h going to 0 in front of every expression. So then we can already calculate So here we can use the binomial theorem, and then further on we can factorize out an h. And then we're left with 2x as h approach, which is 0. So 2x is the solution for this example. So let's just write down some general rules for calculating derivatives. So some formulas that always work, and you don't always have to take the long formula. So for x to the power of n, you can just take n multiplied with x to the power of n minus 1. So for example, x squared is 2x, or x cubed is 3x squared. Then for exponential functions, you can just take b to the power of x and then the natural logarithm of x. So for example, to the power of x is 2 to the power of x, and the natural logarithm of natural logarithm of b, so the natural logarithm of 2. Another rule, just the natural logarithm of x is 1 divided by x, and some trigonometric rules. So the derivative of cosine x is minus sine x, and the derivative of sine x is cosine x. So I hope you liked this video, and I hope I could help you along with the definition of a derivative. Thank you very much for watching. See you in the next video.